Hello, welcome again to Operations with Polynomials Part 3. This is the second part of Part 3 where we have been discussing how to multiply polynomials. So our first example we did in Part 3, we multiplied a binomial times a binomial, which is really just two distributions. And then once we do our two distributions, we end up with four terms. And then we have two like terms that line up in the middle, so we ended up with three terms. So now I'm going to take one of my binomials and multiply it by a trinomial. So let's take 2x minus 5 and multiply it by my trinomial 2x squared minus 3x plus 4. Now before beginning, you should always think about how many terms you have. Here we have two terms. Times. Here we have three terms. Two terms times three terms should give me 6 terms when I'm done multiplying. Now you can do any number of terms. I can do 3 terms times 3 terms. That would give me 9 terms. I could do 1 term times 2 terms, and that would give me 2 terms when I'm done multiplying. Okay. The process is still the same. It's still distribute. So you're going to take your front polynomial, which in this case is a binomial, and I'm going to distribute it to every term in the second group here. So I'm distributing this group 3 times. So here's what it looks like. 2x minus 5 times 2x squared plus 2x minus 5 times negative 3x plus 2x minus 5 times positive 4. And then what I have here is I have another distribution. So now I'm going to take the single term and distribute it to these two. And the single term, distribute it to these two. The single term, distribute it to these two. So 2x squared times 2x. 2 times 2 is 4. X squared times x to the first. Well, since I'm doing a product, that's my product rule for exponents, so I'm going to add. So again, x to the third. 2 times negative 5, negative 10. X squared times x to the 0. I'd still end up with x squared. Negative 3x to the first times 2x. The coefficients, negative 3 times 2 would give me negative 6. X to the first times x to the first. You would add those exponents and get an x squared. Negative 3x times negative 5. That would give me positive 15. And then the exponent rules would give me x to the first. Then my last group here, I have 4 times 2x. That would give me 8x. And then my very, very last term will be 4 times negative 5, which will give me negative 20. Now as you notice here, I have 1, 2, 3, 4, 5, 6 terms, just like I expected. Now they're all lined up in the proper order. So degree 3, then my degree 2s, degree 1s, and then degree 0, or my constant term. So now I'm going to combine my like terms. I have 2 sets of like terms. The 4x to the third will just come down. These ones I'm going to add my coefficients, so I have negative 10 and negative 6, which makes negative 16. However, it stays x squared because exponents are not affected by adding and subtracting. They're only affected with multiplication and division. Here's my first degree terms, or degree 1. So I just add the coefficients. So 15 plus 8 is 23. So I have 23x. And again, the exponent stays the same because I'm just counting. And then minus 20 comes down. So here is my final polynomial, which is a degree 3, because that's the highest one. And it's a 4-term polynomial. Now, as I said before, you can multiply any number. You could do a 5-term times a 5-term, which would give you 25 terms. Typically, we do like this one, where it's a 1-term times a 2-term, or a binomial times a binomial, or a binomial times a trinomial. You may sometimes see a trinomial times a trinomial. Usually anything more than that is just too cumbersome, and we don't do examples like that, but the process is still the same. Okay, that's it. Part 4 will be factoring.